We are discussing about GATE 1993 ECE paper, and this is one more question related to electronics. Look at the diagram. The ideal moving iron voltmeter M will read, where we are applying a circuit consisting of 10 sin 3140 is the input signal that is applied to a combination of ideal diode and 100 microfarad capacitor, and the voltmeter is placed across ideal diode, and what is the voltage across that ideal diode if it is moving iron voltmeter type. Okay, so generally moving iron voltmeters measures RMS value of the voltage. So here we are interested in calculating moving iron voltmeter. Moving iron voltmeter measures, remember that one, moving iron voltmeter measures, okay, RMS value. So that implies nothing but we are going to calculate RMS value of diode voltage waveform. So we are going to calculate the RMS value of diode voltage waveform across that ideal diode. So that we are going to calculate. So first of all we have to know the output voltage equation. From that one we can calculate the RMS value. Okay, so whenever we are applying 10 sin 3140, that is going to be consisting of, sinusoidal is nothing but first you will get positive half cycle, later you will get negative half cycle. So if you are going for this one, this is the first, will go like this. This is input waveform. So initially it is going with positive half cycle, later negative half cycle, later it is going with positive and negative half cycles. So this is 0, and this is the time axis, we are going with omega t, whatever it is. This is first quarter cycle, so this will be treated as omega t is pi by 2, and it is pi, this is 2 pi. Okay, so during first quarter cycle is nothing but during this portion. So from this point onwards, during this point, so during first quarter half cycle, that is whenever the time is going to be in between pi by 2 at most. So the voltages V in is positive, V input is positive voltage, so that diode act as forward bias. Whenever diode act as forward bias, it act as short circuit, and when it act as short circuit, at that time the current flows from this input side, the current is flowing in this direction, it is in short circuit, so that it will be going in this direction. A current enters through the capacitor. Whenever current flows through the capacitor, it gets charged up, and since it is ideal, diode is ideal, that implies nothing but RF, forward resistance of diode is 0 ohms. Now the time constants will become, during charging, RF into C is going to be the time constant, that is going to be 0 into C is 0. So time constant is 0 implies nothing but whenever you apply any voltage, the capacitor directly follows that one. So at that instant itself, capacitor charges to that value. So if the input voltage is going to be increasing from 0 onwards, capacitor simply follows that voltage. So at that time it will go towards the peak value. So at t is equal to pi by 4, at omega t is pi by 4, at that time that capacitor voltage also reaches the peak value, which is nothing but 10 volts. So now the capacitor voltage will reaches 10 volts, and we can draw in this way. This is plus and it minus, the voltage across VC is equal to 10 volts during first quarter cycle. Okay, next. So here if we are going for the same thing, now we will go for the next cycle, that is nothing but after that one, after first quarter cycle, we are applying the 10 sin omega t, but after first quarter cycle the voltage across the diode is going to be, voltage across diode is plus and minus. The voltage is nothing but 10 volts. This is plus and it is 10 volts we are getting. So the diode negative is connected with plus 10 volts. Are you understanding this one? Plus 10 volts. Now there is a possibility that this ideal diode will become forward bias only when the voltage across the P side is greater than 10 volts. But is there any chance of getting that one? Okay, so if you check this one, there is no other chance of getting. So always during the other portions, if you are looking at this one, during the other portions the value is going to be always, it will be lesser than 10 only. This is 9.5, it may be 9, it may be 5, 3, 2, 0, minus 1, minus 5, minus 8, minus 9, minus 10. So at every point the voltage at most it may reach plus 10. By that time the diode cannot become forward bias. So for all the rest of the cycles, okay, after that first quarter cycle, for all of the rest of the cycles the diode will be under reverse bias. Diode will be under reverse bias. Diode will be under reverse bias. So for all the cycles diode will be under reverse bias. Whenever the diode will be under reverse bias, okay, at that time we can draw the equation like this. Diode voltage equation we will draw like this. So this is 10 volts across the capacitor, and the ideal diode, it is under reverse bias. Whenever it is under reverse bias, it acts as open circuit. So that diode voltage is going to be Vd plus minus, and what we are applying is nothing but V input plus minus, and here we are going with a capacitor voltage. For that one it is plus minus. So we can write the equation for this one. Vd is equal to V input is equal to Vd. V input is equal to Vd plus Vc. Vd plus Vc. So from this one, sorry, Vd is equal to, diode voltage is Vd minus Vc. Diode voltage Vd is equal to V input minus voltage across capacitor Vc. So we can write this one as 10 sin 314t minus 10 volts. So this is actual diode equation. So normally we know that one moving iron voltmeter is placed across this ideal diode whose waveform is going to be this one. So this you will get with the help of KVL, and if you measure the RMS value for this one, the diode RMS value Vd RMS is equal to root mean square. So this is peak value. For that one it is 10 by root 2 whole square plus 10 square, root mean square. So the value of this one is equal to 12.24. This will become 12.24 volts. So the RMS value of the voltmeter, the measured value of the voltmeter which measures only RMS value, and that too across, since it is connected across ideal diode, the RMS value shown by the meter is 12.24 volts. So the right option for us is B. So 12.24 is the answer. Thank